Hello, today I want to talk about evaluating linear functions when trying to solve for a missing coordinate, pretty much. So if I'm given standard form or slope-intercept form, it's very similar to finding intercepts. I take the value they give me, and I'm going to substitute that into the equation. And every time I do that, I put parentheses where I'm going to do a substitution. That way, before I substitute, I can still make sure that I'm showing all the right math. So I have a 2x, I have a 3 times a y, and this represents 3 times something. Then I will go ahead and substitute in what they gave me. So y equals 1, so I'm going to put a 1 inside there. And I'm going to do the math. So I'm going to do 3 times 1. 3 times 1 is 3. And then I say what math is currently happening to x, because that's what I need to solve for. And I'm going to undo that math. So it's being added by 3 and multiplied by 2. So I'm going to do backwards PEMDAS. If I'm evaluating plugging numbers into both x and y, potentially, plugging numbers in everywhere, I would probably just go straight down. But since at this point I'm now trying to solve for x, because I've already done the evaluation here, now I'm trying to isolate x, I need to kind of undo everything that's happening to x. So I have to undo the addition subtraction first. So I'm going to subtract 3 from both sides. That's the opposite of adding 3. Bring the 2x down. 16 minus 3 is 13. And then this plus 3 and minus 3, remember that went away, it made a 0 pair? Those are now gone. The math that's happening to x is that it's being multiplied by 2. So I'm going to go ahead and do the opposite of multiplication, which is dividing both sides by 2. And now I get x is equal to 13 over 2. And oftentimes this is when someone's trying to find a coordinate. So depending on what they're asking you for, the format of your answer might be different. You could just say, my answer was x equals 13 over 2. Or maybe you have to actually write your answer as an ordered pair. So you might say that it's the pair 13 over 2, comma 1. Depends exactly on what the question's asking you for. I'll do the same thing here. I'm going to find for the other variable though. So in standard form it looks just like this, but instead of y, we're plugging in for x. Just like before, I'm going to write the equation and I'm going to put a space where I want my variable to be. So instead of x, I'm going to put parenthesis 2 times something plus 3y is equal to 16. Then I substitute in. So I want a 4 inside here. And I'll evaluate, I'll do the math right now. 2 times 4, simplifying that to be 8 plus 3y equals 16. And then I see that I want y by itself. So if I ask what math is happening to y, it's being multiplied by this positive 3 and added by this 8. It's a positive 8. So the opposite of that is subtract 8, because I want to do any addition subtractions first. Then I get 3y is equal to 8. What math is happening? Well, it's being multiplied by 3, so the opposite of that would be to divide both sides by 3. Just like on the last problem, it doesn't quite reduce, so I would get my answer is y is equal to 8 over 3. If this is what they're asking you for. Or if they want the coordinate, it would be x comma y, so 4 comma 8 over 3. So if they want just the variable, it would be this. If they want the whole coordinate, you would have to write it like that. So it might be a good time to see if you can do part B. So you want to pause the video and you can keep watching me afterwards. If not, I'm going to go ahead and continue. If I want to find x when y is 2, again, I'm going to plug in. So I have something is equal to negative 3 over 5x plus 3. I'm going to substitute in. So I want to put the 2 inside here. I'm substituting. So everywhere there was a y, I put a 2. Now I need to solve for x. So the opposite of adding 3, because remember I'm working backwards PEMDAS, the opposite of adding, we'll do any addition subtraction first, would be to subtract 3 from both sides. If I have a positive 2 and I take 3 of it away on a number line, if I think about that number line, I'm going into the negative 1s. Here, I have a multiplication by a negative 3 and a division by a 5. So I need to get rid of both of those at the same time. So the opposite of multiplying by negative 3 would be to divide by negative 3. So I'm multiplying by something, but I'm going to put on the bottom of my fraction, which implies division. I'm going to put that negative 3 on the bottom here. That way multiplying and dividing by that number will cancel out. The opposite of dividing by 5 would be to multiply by 5. So I'm going to put it on the top. Top implies multiplication. The rule is any math I do to one side I have to do to the other. And if it's multiplication I have to do it to every single term. So this is my other term, so I'm going to multiply this by 5 over negative 3. And this is like over 1. This 1 is on the top. So I'm going to put the 1 on the bottom just to make sure I know that I'm representing that. Now, negative 3, multiplication, and negative 3 division, those go away. Dividing by 5, multiplying 5, they go away. So it leaves me just this x. I have a negative and a negative, so those both cancel. And a negative and a negative. And if you need help, there's the baby face idea. You cover up the pieces you have. So if I have a negative times a negative, that makes a positive answer. The other trick that you can say is if you are multiplying or dividing and they are the same kind of sign, so positive and positive or negative and negative, your answer will be positive no matter what. So if it's the same sign, they're going to be positive. If you have different signs, so you have one positive and one negative, so I covered those up, then my answer would be negative. So if they're different, it ends up being negative. The more practice you have, the easier it is to see. So here, I have an x left over on this side. And on this side, my negative and my negative, they go away. Because again, negative divided by negative is a positive. 5 times 1, we multiply straight across. So 5 times 1 is 5. 3 times 1 is 3. So my answer would be x equals 5 over 3. Or, just like before, I need an ordered pair where I have x first and then y. So for this problem, I'm substituting for x, so my y stays, negative 3 over 5 stays, and instead of x, I'm putting parentheses. Now after I make sure that my math is represented correctly and that I'm not missing any negatives or a number, then I substitute in the 10 here. And then I notice that this is really like 10 over 1. And just like over here, I can sort of reduce. If I'm multiplying by 10 and then dividing by 5, they both have a 5 in common. So it's like taking 2 steps forward to take 1 step back. I'm not really going 2 steps forward. So if I divide both of these by 5, 5 divided by 5 is 1. 10 divided by 5 is 2. I can go ahead and reduce that number to make it easier for me. So again, I divided both of these by 5. And as long as I divide the top and the bottom by the same number, it still makes it the same. So y is equal to, and I multiply straight across, so negative 3 times 2 is a negative 6. And then I have a 1 on bottom and a 1 on bottom, so the fraction part goes away. The 3 stays. And then negative 6 plus 3, if I think about the number line, if I'm out at negative 6 and I go 3 in the positive direction, I'm still at negative 3. And like all the other problems, if this is what they're asking for, then you have your answer. If you need the coordinate, however, you would be 10 comma negative 3. So that was evaluating linear functions. Make sure to subscribe. Thank you. Let me know if you have any questions. Please comment, share. Hope you enjoyed.